Okay, so here's a question. You have a light bulb meant to be run at 9 volts, and it's going to have a power of 20 watts, but you only have a 120 volt outlet. So if that happened, what would happen to if you plugged it into your outlet, what would happen to the light bulb? Okay, it would break, right? It would pop, it would overload overload it, it would heat it up, and it would basically burn out. So the question is, how do you solve this problem? So what would you do? How could you get it to work? If you simply plug it in, it's not going to work. So you need to figure out a method, you need to engineer, come up with a plan to get it to work. Okay? So one of the possibilities is to create what's called a voltage divider. Because right now you have way too much current going through your light bulb, so you want to reduce that current down by dividing up the voltage. Yeah?
Could you put like resistors before the light bulb and then, lessen the voltage?
Okay, that's the plan. Yeah, so we want to put some resistors in front of it, and we'll just say 1. I mean, you could use multiples to get to that value, but let's just say we want to put 1 resistor here. Let's say this is our light bulb over here. Remember, the symbol for a light bulb has a circle. So let's say this is our light bulb meant to be run at 9 volts with 20 watts. So remember, 20 watts would be when it is at 9 volts. If you would try to run it at 120 volts, it would be too much more power. I mean, it would be so much it would probably burn it out. So yeah, the key is, let's find an R here. Let's find 1 resistor. Or you can use multiple ones, but let's just keep it simple and just say 1 resistor. So what resistance is needed? That would be the question, essentially. And I think that's the question on your lab. What resistance is needed to, I guess, get it to work? Should just have stopped it needed. So here's our circuit, 120 volts. Okay, anyone know where we can begin? So we're looking for R.
Looking for R. So you can say like 20,
So we can find something right here, right? What can we find right here?
R.
The current. Good. So if we want it running at this amount, we can figure out how much current should be going through this, right? So we know the power. Oops, that's the voltage. We know the voltage. We know the power. What's the equation that relates all three? Okay. So P equals IV. So we're going to go 20 equals I times 9. 2.22.
Yeah.
Okay, so we're gonna use multiple concepts here. So the first thing is we can calculate the current that we want to go through here. So that's 2.22 amps.
We find the resistance.
Then we want to find the resistance. So we need some more things. We only know. Well, what do we know about a series circuit, first of all?
The higher the resistance, the higher. Oh wait, no. Yeah.
What do we know about the current in a series circuit?
It's just all the same throughout.
Okay, it's the same, right? So if I know the current through my light bulb, then I also know the current through my resistor, right? So this should also be 2.22 amps. That's the current through the resistor. So that's one of the concepts of series. There's only one current, therefore they both have the same. Then there's one more big concept. I'll give you a hint. Look at this word. All the voltages should add up to 120. Good. So how does that help us?
The voltage is the resistor.
9 minus 9.
So if this is 9 volts, what kind of voltage do we want to come across this? 111, right. So that's the key, is understanding that these two should add up to the total of 120. Okay? So now we know the current, now we know the voltage. We know 2, right? We should be able to get the third one. third thing. So this time we'll use Ohm's law. V equals IR. 120 volts. 222 R.
Why would you use them?
You're right. I'm glad you're paying attention. At least one person did that on purpose. 111 equals 2.22 divided by R. 50 ohms?
Yeah.
Good. Why do we need 3? We don't need 3. We just need 2. So we just need 1, but we just this was our original light bulb, and then here was the resistor that we added into it.
Thank you.
Okay, good.